Hello everyone, I am Shrivani, online tutor. I have been teaching maths, physics and chemistry to thousands of students for more than 15 years now. I focus on various curriculum. Currently the CBSE has announced MCQ pattern for the board students. Yes, this is a new format. But children, all of you can score good. The only thing you need to do is make sure your concepts are strong. And secondly, with subjects like maths and science, you need to have a smart approach in handling the different models of questions. So in my channel, I will be focusing on the objective part with the boards as well as the entrance. Let's get started. Hello everyone. As all of us know, we have the objective pattern for the boards this year. In this, there are three models of questions. We have the standalone MCQs, assertion reasoning MCQs. We also have the case study based MCQs. Among these three, children find it more challenging with the assertion reasoning type. That's because they get confused with the four options given there. So let's practice few questions on this. Let's do assertion reasoning questions from Real Numbers chapter. Assertion statement is 12 power n ends with digit 0 where n is a natural number. Reason statement is any number to end with digit 0, the prime factor should be of the form 2 power m into 5 power n where m and n are natural numbers. The four options are both A and R. A and R is assertion and reason are true and reason is the correct explanation for assertion. B option is both assertion and reason are true and reason is not the correct explanation for assertion. C option is assertion is true, reason is false. D option is assertion is false, reason is true. So now looking at the assertion statement, 12 power n. We know that for any number power n, like 12 power n, any number like 12 power 50, it could be 12 power 20, it could be anything. To end with digit 0, the factors of this number needs to be 5 power m into 2 power n. Only then it will end with digit 0. Now 12. What are the factors of 12? 3 into 2 into 2. So this 3 into 2 into 2, the whole power n, can definitely not end with digit 0. So assertion is a false statement. Reason. Any number ends with digit 0, it's prime factor. So this is what I just said. So this is a true statement. So option D. Assertion is false, reason is true. The next question. Assertion is sum of rational and irrational number is always irrational. Reason statement is product of rational and irrational number is always irrational. So let's take the assertion statement. Rational number, let's say 3. Irrational number, let's say root 2. Sum of rational and irrational is always irrational. So 3 plus root 2. When you add this, you will get 3 plus root 2 only. And 3 plus root 2 is irrational number. It is irrational. So assertion is the correct statement. It's true. Reason statement. Product of rational and irrational number is always irrational. So rational number, let's say 0. 0 is also a rational number. So let's take 0. Irrational number, root 3. So when you find the product of 0 and root 3, what do you get? 0 into root 3 will be a 0. Is 0 a irrational number, children? No. The reason statement is it says it should be always irrational. But we are getting 0 in this case, which is a rational number. So which means reason statement is wrong. It is false. Because the reason statement will be true only in the case of non-zero rational numbers. Non-zero rational number is multiplied with an irrational number, then it will be always irrational. But if rational number 0 is multiplied with an irrational number, then you get rational. So reason statement is definitely false. So option C is the correct answer. The next question. Assertion statement is 29 by 625 is a terminating decimal fraction. For any rational number of the form P by Q, to have a terminating decimal expansion, the denominator Q should take the factors of 5 power m into 2 power n. So let's take the factors of 625. 625 is 25 square. So it's going to be 5 power 5 into 5, again you have 5 into 5. So you have 5 power 4. So 5 power 4 in the denominator. So denominator is having the factors of 5, which means it is definitely a terminating decimal fraction. So assertion is a true statement. Reason. If q is the denominator, 2 power m into 5 power n, where n and m are non-negative integers, then p by q is a decimal, terminating decimal fraction. Reason is also true, and reason is the correct explanation for the assertion statement. Reason is the correct explanation for assertion statement. See, when both assertion and reason are true, children, you have to make sure whether it is option A or option B. Option A says assertion and reason are true. Reason is the correct explanation for assertion. Option B says assertion and reason are true. Reason is not the correct explanation for assertion. So here reason is definitely the explanation for the assertion statement. So which means option A is the correct answer. The next question. Assertion statement is root x is an irrational number where x is prime. Reason statement. Square root of 1024 is 32. So let's see one by one. Assertion statement is root x is an irrational number where x is prime. Prime number means, let's say 2. Prime number, if you take 2, square root of 2. What is square root of 2? 1.414. It goes continuous. It has got non-terminating and non-recurring decimal expansion it has. So which means it is irrational. So it is irrational. So let's take another prime number. Let's say root 3. Prime number, square root of a prime number, root 3. Root 3 has got the value of 1.732. Again, it has got non-terminating and non-recurring decimal expansion, which is again irrational. So which means that root x is an irrational number where x is prime. So which means that it is a true statement. Reason statement. Reason statement is square root of 1024 is 32. So let's find the square root of 1024. What is the square root of 1024? 1024, let's, you can do it prime factorization or you can do it square root division as well. So when I do square root division, what will I get? So let me separate it from the right in 2 digits. So I have 3 3s are 9, then 124, then I have 3 on top, into 2 is 6. So in 2 and 2 here, 62 into 2 will be 124. It is 0. So the square root of 600 and square root of 1024 is 32. 32 is the square root. So that's correct. Reason statement is also correct. So assertion statement is also correct. Reason statement is also correct. So as I told you in the previous case, in the previous question, when both assertion and reason are correct, you have 2 options. Reason is the correct explanation for assertion. Reason is not the correct explanation for assertion. Look into the question again. Is reason the correct explanation for assertion? No. Assertion statement is talking about a prime number x and the square root of it. Reason statement is talking about a square root of 1024, which is a composite number. So assertion, reason is not the correct explanation for assertion, which is option B is the correct answer. Moving on to the next question. The question says, assertion statement. 3 is a rational number. Is 3 a rational number? Yes, 3 is definitely a rational number. Reason statement. The square roots of all positive integers are rational. Square roots of all positive integers are rational. So, is that a correct statement? Let's take 9. What is the square root of 9? It is 3. Is it irrational? What's the square root of 16? It is 4. So, it is again rational. So, these are all rational numbers. So, which means that the reason statement is wrong. The square root of all positive integers are irrational is a wrong statement. But assertion statement, 3 is a rational number. Yes, it is definitely a rational number. So assertion is true, reason is false. So it is option C. Option C is the correct answer. Assertion is a true statement, reason is a false statement. Next question. The question says, assertion statement 34.12345. this is the number, and it is a terminating decimal expansion. Yes, it is definitely a terminating decimal expansion. When you look at it, and you can write it in the form of 3, 4, 1, 2, 3, 4, 5 divided by 1 to 5 decimal places. So you will divide it by 10,000, no, not 10,000, 1 lakh in the denominator, because it has got 5 decimal places. Yeah, so now this is the denominator. When you look at the denominator q, it has got the factors of this 1 lakh has got the factors of definitely 5 and 2 and nothing else. So 34.12345 is a terminating decimal expansion. So that's a correct statement. Reason: denominator 34.12345 when expressed in the form of p by q. So when expressed in the form of p by q is this form. When expressed in the form of p by q is of the form 2 power m into 5 power n, where m and n are non-negative integers. Yes, it has got the factors of 2 power m into 5 power n. So reason statement is also correct, and reason is the correct explanation for the assertion statement. So option A. So option A will be the correct answer. The next question, moving on to the next question. Here the question says, assertion statement, HCF of two numbers is 5 and their products is 150, then their LCM is 30. So the question says two numbers has got the HCF 5. Product of the two numbers, let the numbers be A and B. Product of the two numbers is 150. Question is telling LCM is 30. So let's check for this. So we have a formula, HCF into LCM equals the product of the two numbers A into B. HCF is 5, LCM is 30. The two numbers product is 150. So 150 equals 150. So assertion statement is true. Assertion statement is definitely true. Reason statement. For any two positive integers A and B, HCF. So we have the formula HCF multiplied by LCM is A into B. So this is our formula. But when we look at the formula, see, in a hurry, children, you don't look at this plus sign, you will mark the wrong answer. Look at it properly. The question, according to the reason statement, it says HCF plus LCM. So which is definitely a wrong statement. It is not the formula we have. We have product of HCF and LCM equal to product of the two numbers. But there is a plus sign here. There is a plus sign instead of multiplication. So reason is a false statement. Assertion is true, reason is false is option C. Option C is the correct answer. So that's all for assertion reasoning questions today.